Okay, gang, we're back with 7.2, which is highly, strongly related to 7.1. So we're going to do these two kind of small sections together. So this particular one is called Stoichiometric Relationships and Chemical Reactions. So we'll get to what that word means in a second. But we saw in the last little section, 7.1, that when we talk about ratios of one particular substance to another in a chemical reaction, what we're looking at is the mole ratio. And those mole ratios are established from the coefficients. So those numbers that are in there or that we insert in order to balance the chemical reaction. So that's why when we were way back in class, balancing the chemical reactions is so important that we do correctly, which is why nomenclature way back is so important, that we get the chemical formulas correct so that we can balance the equation correctly so that we can move on and do what we're doing now. So what we're getting there is the relative amount of one chemical that has to react with another. We can also predict the amount of product, which is a pretty valuable one. So if I have this much of hydrogen and this much oxygen, how much water can I make? So that way I know if I need a certain amount of water and this is how much I can make, I know if I need to get more of one reactant or another and so on and so forth. So this kind of study, these relationships between the reactants and the products, that's called stoichiometry. Okay, so we're looking at stoichiometry now. We're going to look at stoichiometry in Unit 4 throughout. So basically what we're going to look at here for a large part or the majority of the rest of Chapter 7 is this little relationship right here. So what we're going to be doing is, in stoichiometry, we're going to be given the mass of one of the reactants normally, or a product, but one piece of the chemical equation. So what we're going to do is use the molar mass of that substance, find the number of moles of the substance you have. So it doesn't matter where it is on the chemical equation, find the number of moles of what you have, use the mole ratio, which are the coefficients from the balanced chemical equation, to find the number of moles of what you need, and then use our N equals M over M, mass over molar mass, to find the mass of the substance that you need. Most of the time we're finding mass, but they may mix it up on you a little bit as we go through. And in your questions, they may mix it up and ask you to find the molar mass or find something else. But for the most part, that's what we're looking at. So little example here, and I'll walk you through this particular Sarah. So it's basically, it's always going to be the same thing. So get the balanced chemical equation. Now, normally they're giving it to you in this particular one. So I'm going to do one for you here. It's an example from the note. 2NaN3, which is solid. It's going to give us 2Na plus 3N2, gas. Okay, so here's a chemical reaction, and we're going to have, in this particular one, this is an automobile. This is when sodium azide, which is over here, decomposes, you get nitrogen, and it's that chemical reaction that inflates an airbag. Okay, so what we're looking for is, they say if we've got mass of nitrogen fully, we've got 87.5 grams of nitrogen. Okay, so it's asking us what mass of sodium azide was present over here in that particular reaction. So we've got the mass of one piece. So the first thing we're going to do always is find the number of moles of what we have. Step one, number of moles, in this case of nitrogen, which is what we have, N equals 87.5 grams divided by, remember, we're talking about the molar mass of the substance. So we're going to be careful. People make mistakes sometimes. Molar mass, it's of N2, nitrogen gas. So it's not 14.01, it's 28.02, because there are two nitrogens, remember, in that particular substance. So we do that division, our grams are going to cancel out, and we're going to end up with 3.1228. 1228 moles. Extra significant digits, remember we carry those because the more precise we are, the closer to whole numbers we will get in our ratio comparison. Speaking of ratios, that's number 2. We're going to use that mole ratio now. So the ratio of what you have, nitrogen, to what you need, NaN3, in this case is 3 to 2. Okay, that's a 3 to 2 ratio. So how do we calculate that? Well, we take 3.1228 moles of nitrogen. We're going to multiply it by 2 moles of NaN3 over 3 moles of N2. Okay, we set the ratio up this way because when I do this multiplication, I need my number of moles of nitrogen, top and bottom of the fraction, so they cancel each other out, leaves me with moles of NaN3. So I'm going to take 3.1228 times 2 divided by 3, okay, which is going to give me 2.0819. 2.0819 moles of NaN3. Okay, now one thing you can do when you get these numbers, just look right away. If the ratio is 3 to 2, it means automatically you're going to have fewer moles of NaN3 than you do of N2. So this number has to be smaller than 3.1228. If it's not, then you've done something incorrect. So then our last step is pretty simple. Mass of NaN3. Mass equals number of moles, 2. Sorry, I thought I hit stop there. 2.0819 moles times. Now, this is where we're going to find the molar mass. So if you don't have it, you would have to calculate it here. But it is 65.02 grams per mole. Our number of moles there would cancel. We'd end up with 135 grams. All right, so there's our last piece of that calculation. Sorry, lift it up a little bit. Okay, so the steps are going to be the same throughout this particular chapter and throughout this course. Okay, so balanced chemical equation number 1. Generally, they're going to give you the mass of one of the things that we have. Now, this calculation going forward, the rest of chapter 7, chapter 8, chapter 9, this is an essential calculation to be able to do. So, we've got the mass of one of the substances. First thing, find the number of moles of what you have. Use the ratio of what you have to what you need. Do your conversion. And then find the mass of what you need in order to solve that particular problem. Okay, same steps over and over. They can add some things in to try and make it look trickier, but it's the same thing all the time. Number of moles of the thing you have, then use the ratio to find the number of moles of the thing you need, and then use the mass over molar mass, number of moles equals mass over molar mass, N equals M over M triangle to find the mass of what it is you're looking for. Okay, so hopefully that's pretty clear. If you have any questions, lots of people have been posting questions on there, and I'll put them on as answers again. But essentially, you're looking at a 3-step calculation. Now, you may include a second or third, an extra step here and there. Like you might have to do a conversion, because remember, you're dealing with grams per mole as a molar mass. So if you're using the molar mass involved in something and you get a unit in kilograms, you've got to convert kilograms to grams in there. So they don't include that as one of the steps, but it is something you need to do. And the other possibility is, like we saw in this one, NaN3 was what we had to find the mass of. So in order to do that in that last calculation where the mass equals the number of moles times the molar mass, if you don't have the molar mass, it's not given to you, then you've got to calculate it NaN3. So 14.01 plus 3 times 22.99 plus 3 times 14.01 would give you that molar mass that we have. Okay, so try those. I'm going to post some more videos on Thursday, sections 7.3 and 7.4. Those are the same thing here that we just did. We're just going to add a couple pieces of information to it and to differentiate between one thing and another. But it's still going to be number of moles, ratio, mass. So we're still going to use the exact same thing we're doing here. So it's real important that you do these ones ASAP. Give me any questions so I can clarify, and then I will get back to you. Okay, good luck, and look forward to hearing from you guys.